Think it's about time. Hello and welcome everyone once again, and thank you for joining us today. I can still see a few people logging in, but we should get started now. Right. So before we begin, I'll just give a quick introduction about us, technology, about us, WalkingTree Technologies. We are a technology-focused company, and our approach to the adoption of AI and intelligent automation is human-centered, pragmatic, outcome-focused, and ethical. We harness AI, automation, and predictive capabilities to streamline processes and navigate the future. Our suite of strategy, design, architecture, data, and integration, system integrations is combined with our deep domain and sector knowledge. Today, we have three speakers who some of you would have recalled from some of our recent few webinars that we have conducted. Starting off with Scott, who is our CTO. He has been a problem solver, an entrepreneur, and a technology leader for over 30 years now. Under his leadership, we have been able to establish a wide range of digital and data analytics capabilities and an enviable client-centric innovation culture. He's also helping our clients and the WalkingTree team with the big picture insights and new thinking that allow them to act decisively in solving challenges, seizing opportunities, and sparking innovative growth. Abhilasha has more than 16 years of experience in leading high-performing teams and building enterprise-scale products and applications. This includes over a decade of experience in leading end-to-end design and development of sophisticated analytics solutions across diverse industry segments. Lastly, we have Shubham with us, who has been with us for the last 4 years and takes great interest in solving the last mile problems in analytics. He comes with hands-on experience in ensuring continuous delivery of innovative software solutions. That was about us and our speakers. We will be starting with them now, but before we do that, we'd like to have, we will definitely be having a lot of questions and queries or doubts and clarifications from you. Please put those in the Q&A box. We would definitely try to address as many as we can after the speakers are done with their bit. So that's it from me. Over to you, Scott.
Okay, thank you very much, Prince. Thank you for those of you who are returning to these webinars, and especially those of you who attended the last GPT-3 webinar. Welcome back. For those of you who are new, we're so glad to have you. As Prince, you mentioned, we're passionate about GPT-3, and I know especially Shubham is excited about going into some more detail. But just to kind of give you a little roadmap of where we hope to go today, and that is going to be, first of all, we'll talk a little bit about training of GPT-3, and then we'll look into fine-tuning of GPT-3, and that'll be Abhilasha that covers that part, and then Shubham will step in and talk about, specifically the demo for GPT-3 fine-tuning and best practices. So kind of those 5 areas are where we're headed today. Just so you know, just as we get going and you don't get lost, you know where we're headed. So, what is GPT-3? So maybe some of you are coming and you're just new to GPT-3. It sounds cool. The technical name for it, right, is generative pre-trained transformer, and it's basically it's a neural network machine learning model that's trained using internet data to generate any type of text. Okay, so it's developed by OpenAI, and it requires really just a very small amount of input text to generate large volumes of relevant and really sophisticated machine generated text. And what's really neat about this is just how it was trained, right? And that model, the model has over 107 billion parameters that it was trained with, right? So you can see that GPT-3 has been used to create articles, poetry, stories, news reports, dialogue, And so many uses for GPT-3. And let's look at some of those maybe areas, right, that either is used for or it could be used for. And, as we've already spoken, like content generation for different markets. Won't name every single market, but you can kind of see, just some of the areas that GPT-3 is or can be used for, right? So things like copywriting. So you get into spaces like marketing and retail, healthcare, pharma, education, question answering, grammar correction. And trust me, I've tried some of this, and my grammar overall is pretty decent, but with GPT-3, it even corrects me for sure. So, and then the other areas are things like translation, which can be used in many different industries. Then summarizing. Then chatbots are another area. Chatbots have, are used extensively now, right, in many different situations like banking or insurance, even healthcare, retail, pharmaceutical, e-commerce. So most any site you go onto now, you'll see a chatbot. Now, I think what is really cool about GPT-3 is it takes that chatbot experience to a really different level, right? So a chatbot utilizing GPT-3 really is enhanced, and we'll see more and more relevant, intelligent when you see it. So the other areas around like influencer marketing, and then things like entity recognition, classification, and those are used in different areas, right? Classification around pharmaceuticals, banking, insurance, healthcare. So different segments, retail as well. And then we talked a bit about this last time, but sentiment analysis as well is an area that GPT-3 is utilized. And then, a kind of a cool area for, a lot of us in IT is around coding as well, right? So we see GPT-3 used in that setting as well. So kind of the point being, if you look at this, there are many use case types that GPT-3 can be used for. And I think we're probably on the cusp of some of these and really just realizing how powerful GPT-3 can be. So it's an exciting technology and by OpenAI. And I think you're going to see some good stuff too when we go into the demo area. So, well, how is GPT-3 so intelligent? Well, GPT-3, as we kind of saw earlier, using a lot of data, right? So GPT-3 was trained with a Common Crawl data set. And that's after doing, a fuzzy deduplication to prevent redundancy in it. And as well as other, known high quality reference corpora that's also utilized in there to increase the diversity of our data sets. So large volumes of data. And to give you an idea too, that Common Crawl data was downloaded from 41 shards of monthly Common Crawl data that was from 2016 to 2019. So it constituted 45 terabytes of compressed plain text. And that was before the filtering went on. After the filtering, it was 570 gigabytes of plain text. So you can imagine that's just a ton of data. And for those of you who are familiar with byte pair encoding tokens, that's equivalent to 400 billion byte pair encoded tokens. So large set of data. And diverse data, and it's based on scaling laws for neural language models. So the larger the model, the larger models were trained on really fewer tokens than a typical model would be, and as a consequence of that, we'll see in a graph later too that GPT-3 billion is almost 10 times larger than the Roberta Large, which is around 355 parameters. So, and then both models, as we'll see in a graph, both models, and you can see with GPT-3 being 10 times larger, they both used around 50 petaflop days of compute during pre-training. So GPT-3 is also efficiently uses its compute resources too when it was trained. So looking a little deeper into the data sets used to train GPT-3, and by the way, this was taken from a really nice white paper that the OpenAI created, and a lot of good data in that. So this is just kind of a summation of some of the data that was pulled from there. And if you look at the Common Crawl filtered data, that's around 410 billion 410 billion tokens basically. And the way they did that, right, the training was done in a weighted fashion, right? So and you can see here from anywhere from 60 down to 3%. Now, what are some of those, right? And as we look at the epochs elapsed training 300 billion tokens basically, as you look through this, you might see Common Crawl data was 410 billion. Then you go down to like, book web text 2 or Wikipedia, and you're looking at much smaller numbers, right? So 3 billion, from 410 billion down to 3 billion. Now, what you'll notice is the weighting there, right? And then the epochs for training. So basically, in terms of like Wikipedia data, that data was sampled, 3.4 times during the training versus like the Common Crawl data, which was less than 1 basically. So it didn't go through that whole set. But the difference being in some of these, just like in the web text 2, is maybe this data is a little higher quality data. So you're sampling that data less data, but sampling it more. So, but it is higher quality data. So that's kind of gives you an idea of just some of the breakdown of the data sets that were used to train. I won't spend too much time. I know that you really kind of want to get down to the details and demo. So, but just to kind of back up some of the things I was talking about before, when we talk about total compute used during training, if you look at this graph and this training, it's really training petaflops days versus, really the amount of data. And I think a neat thing to look at here is, like I mentioned before, that Roberta Large. You can see this is about 50 petaflop days versus when you come over and you look at GPT-3 3B, used about the same amount of compute, right? So very efficient use of compute resources in terms of GPT-3. And again, you can also see, some of the amounts of data that was used. And by far, GPT-3 used just a ton of data to train. So this cool looking graph is really based on validation loss versus the compute and the number of parameters. And kind of what to take away from this, especially if you're a data scientist, you probably already recognize this graph to some degree, and it's really the fact that the validation loss, or really the technical term for it is called cross entropy validation loss. And essentially, if you're not that into statistics and data science, right, basically you want your entropy or your validation loss to be around 0, right? 0 being a perfect model, and which is really, perfect model is hard to obtain. But if you look at this, you'll see that this line this graph looks very familiar if you know anything about power law, right? So essentially what we're saying here, what this graph is showing, that is, it's basically the trend follows a power law, in that, a change on, a relative change on, one quantity results in a relative change in another quantity, and in this case it's the power, right? So some power of that quantity has changed. So in other words, as we are training this, as we increase our compute, increase our data, right, we're getting we're getting closer and closer and getting a pretty good model with this, essentially, is what you can see in that. So we're not getting a lot of validation loss as we increase parameters and compute power. So, so anyway, very efficient, very good training model based on a lot of data and really using compute resources as well. So, and I think we've got a link to this white paper that has all the very good detail in there about how this was trained. So we'll share that with you, I'm sure. So that's kind of, the area of how it was trained, with the amount of data it was trained. What's a little bit about GPT-3 for those of you who don't know. I think what will help a lot is when you start seeing the amount of, text it takes to generate something really cool. So, so with that, I'm going to turn it over to my counterpart, Abhilasha, and she's going to talk a little bit more about, the pre-training of GPT-3, some of the limitations and so forth. So, Abhilasha, I will turn it over to you.
Powerful processing which has gone into GPT-3 and the power of GPT-3. But there are still some limitations and some possible improvements which we can think of. So as we saw that it is trained on a generic data set. So obviously it will not perform the best if you want to cater it to a specific industry to solve a domain specific problem. And that's where there's a need for tuning. So obviously the model is already pre-trained. So just by giving some inputs, it will start picking up and giving better accuracy for domain specific use cases. So that is where this tuning or few shot learning comes into picture. So if we move on to the next slide. So how does GPT learn these domain specific tasks? So there are two ways to it, the K-short learning and the fine tuning. So we will look into fine tuning in detail, but before that, let's look at what is K-short learning. So when we speak about K-short learning, it's more about giving few instances or prompts to the model so that it understands the problem and tries to give a more suitable response. And here we have three types, the zero shot, one shot, and few shot. So as the name suggests, zero shot in which no demonstration is given, only a statement instruction is given to the model describing the task it is supposed to perform. So obviously it is challenging for the model, and but then there is a upside also, that it is robust and it will not be influenced by anything, and it will take its best decision and give you a response. But with one shot, you give one sample or one demonstration of what kind of behavior you're expecting from the model, and accordingly also give the instruction. So it's like, in addition to zero shot, you give one example based on which the model picks up and gives you a result. And lastly, the few shot. So in this case, you will give some set of examples. So it could be 10 or 100, depending on the kind of model you're trying to achieve, or the kind of response you're trying to achieve. And so you will give, like, say, you give 9 examples and the 10th question. So based on the 9 examples or prompts you give, the 10th answer will be given by the model. So that is how it will provide the completion. So these are so whenever you start looking at improving your accuracy, this would be the first thing to do. That is K-short learning. And with this, we can, so I have included some references from some papers based on different data sets when they try to apply K-short learning on GPT-3, how the performance like changed or improved. So moving on to the next slide. So K-short learning, as we see, it delivers on new kinds of tasks by giving prompts or examples, and the model will take a few demonstrations and give the best response at inference time. So it's like a conditioning which you're doing to the model, but the model remains the same. That is the common model, which is temporarily behaving based on the prompts which you give it. moving on. So this is one example, if you're giving the problem statement or the description that suggests 3 names for an animal that is a superhero. And then you're giving 2 examples where animal is cat, and then what could be the, like some jazzy names if it is a superhero. Same thing for a dog. So you're giving 2 examples and you're giving the problem statement. So next question would be, you will give a third animal, and then GPT-3 will come up with some names based on the kind of behavior of the animal and like bringing in some superhero attributes. So that's how it learns, and then it gives a response. Now the second example is from a Lambda data set. So here what happens is, like there is a statement, and then you have to predict the end of the statement. So the completion of the statement in a single word. So the first one is an example, and then the second one. So based on like we are talking about baseball equipment, a ball, a glove, and a, so GPT-3 can respond with a bat maybe. So it knows that we are talking about baseball equipment from the context which is set in the first part of the sentence, based on which it will give you a response. So for this purpose, as we move on to the next slide. So these are some of the data sets which were used for the K-short evaluation. And like usually whenever a model is assessed and evaluated, there are some challenge data sets which are used to see how the model performs on different behaviors and different expectations. So Lambda, we saw the example in the last one. So where you have a sentence and you have to predict the last word of the sentence based on the context you get from the remaining part of the sentence. Similarly, you have these others, like Hella Swag is another popular one, wherein it's like you have one sentence and then you have a possible next sentence, and there'll be like 4 possible outputs or 4 possible options, and the model has to predict which is the real next action for the first sentence. So again, this is like this is actually called adversarial filtering, wherein this data set actually tries to confuse the model with the kind of examples or data it has, which is like very easy to understand for a human, but for machine it is not very direct. So that's where we try to assess how it improves. Similarly, there are other scenarios like this story closes, to do with like there are stories of 5 sentences long, and then you have to give the last ending sentence of the story. And trivia QA is it's like a reading comprehension and the followed question and answers, how we used to do it. So these are different ways the models were assessed, and then these are some of the accuracy ratings which were seen as we started with a 0 shot, and then we gave a 1 shot, 1 demo example, or a few shot, and then there was improvement in accuracy, as you can see, but then it was still not at par with the SOTA model. So when you say SOTA, that is state of the art models. For every problem, there are some models which like perform the best, and that is what is like the benchmark for that behavior, and that is what is used for comparison when we try to assess other models. So this is a kind of comparison of the accuracy. And as we move to the next slides, so these are some other references from the same paper, wherein it shows like how with the increasing of the number of parameters in billions, that is, as you go to the right on the y-axis, it is closer to your GPT-3, the best model which you have, the Da Vinci, and then on the y-axis, you have the accuracy. So as you can see, with 1 shot, few shot, the accuracy slightly improves, and it is almost at par with a 0 shot SOTA model. But obviously it is still like it's in the 80s range. Similarly, this is for the Lambda data set. And similarly, the next slide you can see is for the trivia Q&A. So this is just to give you an example of how just by prompts also the accuracy can be improved, but it will only be for the given for the given set of prompts and for the given session when you're trying to try this out. This is not something which will persist because you're doing in the common model. With fine tuning, what are the benefits we can see? Now we can understand as we move to the next slide. So with fine tuning, it improves the accuracy on top of the few shot learning, as you're actually providing a proper data set catered to your requirement. You are definitely going to achieve better results for a wide variety of tasks. Also, once the model is fine-tuned, then that model is available for use, and you can further improve it. So you don't have to provide a prompt as you do it during runtime. Also, fine-tuning makes GPT-3 more accurate for wider variety of use cases. So you're actually widening the horizon of what problems GPT-3 can solve in a more specific way. So as we go to the next slide to see the advantages and summarize on the advantages of fine-tuning. So as you can say, higher quality results definitely than the prompt approach. Ability to train more examples by giving specific data. Token savings also, because you're not, when you give prompts, obviously you're consuming your tokens and you are built on tokens. So once you have trained your data, so your model is ready for consumption, and you can save if you can properly plan and use it well, train it well with proper data, with removing junk, obviously, because training also will be charged, but then that is on a lesser side. So then you can achieve better savings. And finally, lower latency also, because your model is ready to respond. It's already trained, and you will get a better response immediately. So before we move on to the demo, this is one specific case, which is like another challenging research data set, which is like to solve grade school math problems. Now, these are the word problems, and word problems are like you have to do in a step-by-step or sequential manner. It's not like a direct, so it's a multi-step reasoning problem, and this is where most NLP models struggle. So it is not a easy to achieve thing, because with every step, the model has to decide what will be the next step, and there is a possibility, more possibility of error, because the link has to stay. So even with fine-tuning GPT-3 for this data set, there was significant improvement, as you can see, like 2 times and 4 times for Curie and Da Vinci. So this is like, even though it is still reaching like a 70 mark, but it is really good for this data set, because this is considered to be one of the most challenging data sets in NLP. So as we will move on to the demo, we'll see more cases of how fine-tuning improves. But this is one of the industry cases, so that's the reason I've included it here. Moving on, we'll just look at some of the apps which are powered by a fine-tuned version of GPT-3. So these are like specific, domain-specific solutions using GPT-3. And the first one here is a fintech-based application, Keeper Tax, which actually is trained using the financial statement data. So it understands the data, and it is able to tell the users what are the expenses in their bank statement, which can be used for tax deduction. So it's like, it will help you save taxes, basically. So moving on. The second one here, the Viable app. So this is actually making customer feedback very easily and in a nice format available to the user to make sense out of it. So basically what it does is, obviously, if you are using a CRM system, you will be getting lots and lots of feedback from multiple customers. So this consolidates, summarizes, and gives you in a proper format, which will immediately allow you to make decisions out of the data be it the text data, because obviously if it's just ratings, it is much more easily consumable. But with lots and lots of data in text format, you really want something to summarize and give you in a concise way, like whether it is a good feedback, whether it is a bad feedback. So that you can do quickly using this app. The third example here, this is a learning education LMS system, and this has been trained using their own data, which is like the training content, and then it is used to generate question and answers based on that content. Also it is used to generate more content, so based on the already existing content. So when you just try the normal GPT-3 model, it will give you data which is grammatically correct, obviously, but then with the fine-tuned model, you get a more specific output, which is like exactly as per the needs of your business. So that is what the tuning flavor adds to your model. The last example here is a research app. So this is again, this is trained using all the research data, and this is used for research and brainstorming, where it'll, like, you can ask questions and it'll give answers, and then it'll actually give you a automatic like next step of your research problem. So if you're trying to achieve something, it'll be like a very interactive question and answer session which you can have with the model, and it'll give you the best possible next step based on all the data, all the research data it has been trained on. So with this, like, I would like to pass on the baton to Shubham, where he can actually show you how fine tuning is done, and maybe compare few cases and scenarios. So over to you, Shubham.
Thanks, Abhilasha. Hi, everyone. Please give me a minute. Thanks, Scott and Abhilasha. Now I'll be starting with a demo on fine-tuning of GPT-3. And as Abhilasha mentioned, and as Scott also mentioned earlier, GPT-3 is a very, very powerful model. When you use GPT-3, you don't really have to bother about the language capabilities of the model. It has already been proven time and again that the language capabilities of GPT-3, be it English or in fact other languages, are at par with, almost at par with human beings, if not exactly. In fact, human beings would do mistakes, but GPT-3 wouldn't do those kinds of mistakes because it's anyway a machine learning model. It's a machine working and focused on that exercise. Now, when we have to tune GPT-3, it's important that we have some data set created for it. In this demo, I will be demonstrating to you two use cases where we fine-tuned GPT-3. So this exercise is on fine-tuning GPT-3, as Scott already mentioned. Training is something is not that we do here. For example, to train GPT-3, you really need a lot of resources, and it's better to use the pre-trained model and then fine-tune it. So GPT-3 is like, maybe you could consider it as a fresher of just passed out, whom you take because he has lots of skills, good skills, but then you need to train him on the required job. So the two problems which I'm going to consider as regards fine-tuning are related to, one is related to the financial services industry and the other is related to food industry. So let me start about the first use case, which is actually related to Securities and Exchange Commission filings. So all the public listed companies in the United States have to submit their filings with the US Securities and Exchange Commission, and some of those filings are also publicly available. As you can, for example, I downloaded the filing by Facebook for a couple of years, and if we take the normal GPT-3 model, if we ask it a question regarding those filings, it may or may not be able to give the right answer. So if you of course ask it who is the CEO of Facebook, it will give you the right answer. It'll talk about Zuckerberg, as in Meta, it'll talk about Zuckerberg. And if you ask a question as regards who was the CTO or how has Facebook or Meta been performing over the last couple of years, it would give you some reasonable answers. But if you look at the filing, of course, this contains a gold mine of information. This has lots of tables which have data as regards compensation, as regards bonuses, and so on. and it's a industry specific document. It's not a generic document. It's not something over which you would ask maybe a 15-year-old person to write an essay. So what I want to hint by that is, this is not something which a pre-trained model will be able to answer exactly. There is a lot of text for which you need to fine tune it on domain specific information. And this also has lots of tables, as you see here. And to be able to extract information from these tables, you cannot rely on the pre-trained GPT-3. You need to have a data set created for these tables and graphs, so that you can actually call for, you can have a better model, a refined model, which can be called for doing that analysis as regards the figures and information stored in graphs, and also maybe in photographs, if there are any images with any document. So this is a very intensive document, a very industry specific document, for which for the purpose of this demo, we decided to fine tune GPT-3. And to be able to fine tune GPT-3, you need to have your data set in a certain format. Of course, it's not a model which we are designing, for which we would actually we have greater freedom to pass the data set as we would want to, right? It's something which is already designed by OpenAI, and OpenAI has listed strict conditions in which the strict formats in which we need to pass our data sets for them to be fine tuned. So let me show the case with fine tuning of GPT-3 with respect to this SEC filing. So when you have to fine tune GPT-3, now my objective is to fine tune GPT-3 for a question answering use case. Well, I need to be able to answer questions. I need to be able to get answers to those questions which are related to a particular filing. And this would help in n number of ways. This could be a potential gold mine for different industries, right? It's not just related to Facebook or as in FANG companies. It could be any company. It could be, well, it could be Rexon, it could be oil and shipment companies and so on. So what we do is, because we have to import those learning capabilities to GPT-3, we of course have to teach it a bit. Now the difference is, what we do in fine tune in K-short learning, we provide a few samples and then it tries to learn. But then as Abhilasha and we mentioned earlier, the accuracy there is not so great, because it is something,
Hey,
again,
Shubham,
it's like a question.
Hey, sorry, Shubham, to interrupt. Can you minimize your participant window
Oh, I'm so sorry.
in Zoom?
Is that better?
Yes, thank you.
Thanks, Scott, for that. So what I was trying to come to was that if you have to fine tune GPT-3 for such a specific document, we need to, if you just give it prompts, that will enable us to understand, enable it to understand something. But it's like, say you are from Europe and you live in, say, Germany, you know German, and now you travel to, say, Denmark, and you need to know Danish, and I just give you 3 prompts to understand, right? You wouldn't really be able to make a lot of out of it, right? You may be a very intelligent person, the most intelligent person in the world, but then what does 3 prompts help you, right? You need to have a good data set, reasonable data set. That's how we human beings learn, right? Similarly, for fine tuning GPT-3, you need a similar data set. And what we did, for example, for this use case, we had some paragraphs, curated paragraphs, for which we had question answer pairs, and these were used in fine tuning GPT-3. Now, the way you fine tune GPT-3 for any data set, so I'll be taking 2 cases, is using a command. So that command is, you take your of course, to be able to do any exercise around GPT-3, you need to have an API key, which you get when you create an account with OpenAI. Once you get that API key, to be able to create a fine-tuned model, what you got to do is, you got to have a file in the JSON-L format. It could be in other formats like CSV and JSON as well, but as a standard, we use JSON-L. And there are tools which are available. So if you have a CSV file to start with, for example, I had, as I was showing, to be able to convert it into a data set which is accepted by OpenAI, you could use some tools like, so this OpenAI library. So when you install OpenAI, you have to do pip install OpenAI. With OpenAI, you have some command line tools like OpenAI tools, which you can use to convert this data set into a format that you require. However, what I've seen is, and as is mentioned in the documentation as well, there are version issues with it. So for example, if you're using a Python version like 3.6 or 3.5, it is not possible to make use of OpenAI, some components of that library as in OpenAI tools, where you want to do the conversion of the data set. You need to have something like 3.9 or at least about 3.8. But another way of doing it, why not write a simple code to do it, right? So for example, what I did was, I had a CSV and they required information in a specific format, which was like prompts. So you have to have 2 kind of keys, one is the completions and one is the prompt. And if I may show what it looks like after the conversion. Give me a sec. Scrolling, it's taking time to scroll down, but then essentially what you have is, since we have to train the model with fine-tuning capabilities around question answering, we got to provide it the reference text, and that needs to be passed as a prompt with which we will pass a question, and then we will pass a completion to it, which will have the answer to those questions, one or more questions. So I'll come back to it as well. If it's better if I just give it a sec and then come back to it. So what we do in that case is to be able to fine tune. I'm sorry, there is noise around, but can't help. So we use this command where we pass the information. So I'm using another data set here, which is the popular dishes data set that will just come to. But once we do that, it launches a job, and that job, well, by and large, it executes well. But there are times, so once you execute that, what you have is something like this. So it starts fine tuning. So it creates a fine tuning job. It tells you how much it is costing, and it enqueues your job for the fine tuning exercise. And there are times when it gets interrupted, because after all, the request is sent to the server, and the server has to process that request well. And if there are cases when the request is not processed fully and there is a disconnection, then what the server does is it actually returns that response that the stream is interrupted, but you can always resume it back with the help of another command. You can follow it up on the particular job ID, and then it iterates with the required approaches, and it creates a fine-tuned model which you can use. You can also list the models which get created using the OpenAPI fine-tunes list. And as you can see here in this list, we have this is the walk. So you could either give a name to the model if you wish, or the model will actually, so what OpenAI does is it looks at type of model which you're using, it looks at your account, what kind of account you have, it looks at the date, puts them together, and what you see here is a WalkingTree model trained around financial services by using the base model, which is DaVinci, and we can directly use this model for our purpose. So the app which we created, so we have two apps. One of the apps which we created for this purpose is around financial services. So the idea is that this has to be a document. This is an IRS. So an IRS for financial services. An IRS is a document, is a platform, an information retrieval platform, which enables you to extract information from SEC filings for financial services. So for example, just for the purpose of demo here, when I was asking it, what was the profit of Facebook in 2018, right? On this fine-tuned model. So if you look at the code, for example, for this, then this this code actually points to the DaVinci WalkingTree Technologies model. So for that, it gives you the right answer, right? It gives you some figure, $15.9 billion. Now, if you were to ask this question to the pre-trained GPT-3, now pre-trained GPT-3 may not even have information as regards it, right? Because, well, it could potentially for some cases, but then it doesn't generally wouldn't have generally. So that's one use case where we were able to extract the information using a fine-tuned GPT-3. Now I'll come to another use case. In the interest of time, I'm a bit fast. The other use case which we picked was around Europe, and well, like India, Europe has well, Europe is a continent which has a number of countries, around 40 plus countries, and each country has its unique cuisine and so on. So what we did was we designed a mobile app for the purpose of this demo. It's essentially a Flutter application. So it's a foodie's paradise. So what on this, what you can do is you can just log in, you can check the food item you are interested in. Well, you're feeling hungry, you may want something which is like light, but then still sweet, and you may have other preferences, but you don't know, right? Now, if you just ask GPT-3, it will give you some output, but then that output will be a generic output. After all, GPT-3 is not a model for cuisines, right? But if you want to use that model for cuisines, or for some other requirement, specific requirement, you would rather fine tune it. So what we did for that case is, again, we had a data set around popular cuisines, And this data set was for different countries of Europe, because we wanted this model to have the capability to provide information around European countries. And if you see here, we have a good question set as regards European countries. So there are about 500 questions, and we also provide the answers there. Now, with this, we have a document from where we are getting this information naturally, because this will enable it to get fine-tuned. So it has to learn where it has to extract, right? So it's like a fresher will be trained with some material and then ask questions on that. So you need to have the reference material as well. So in this case, we use Flutter, and well, Flutter is one of the frameworks to do it. You could use React Native as well. You could use any framework which has GPT-3 support component right now. It's easier that if you have a component for it, and Flutter has GPT-3 Dart component. So other reasons is that Flutter from Google easily integrates with other requirements of yours. For example, if you want to build conversational AI, so Flutter has good explicit components designed for those use cases. You don't have to implement things. If you want to have a system where you want to do a video chatbot, Flutter enables that. So for example, Flutter integrates with Agora and enables you to have interaction with video chatbots. So those are use cases where Flutter is actually has already existing packages, well-designed integrations, well-tested integrations, not just for 1 year, but maybe for 2 years. And so it's good to use. And we at WalkingTree Technologies, well, we have an expertise across different frameworks, but in this case, because this was like a good case for Flutter as well, so where we might incorporate conversational AI facilities as well, I decided to use Flutter. So if you see, I have a question here. Say that I want 3 popular German dishes, and it answers the popular German dishes are I'm not sure I'm pronouncing them the right way, but is pronounced and Sorsten. And I was asking what was the best dish, and it tells me that the best German dish is Sorsten. So the answers which it is getting is actually from GPT-3. So the entire Flutter code is actually referring to the fine-tuned models. So if you see this, so there are 3 models here. One is the financial services model, which was 2 models. One is the financial services model, which was fine-tuned a while ago. This was around 7 days ago, because this really required heavy documentation and was done earlier. And for the purpose of this demo, I in fact created another model which was around popular food items. That's why I refer to this popular. This is .jsnl. Again, you use the same CSV, or you could have another. Well, you could have different files to start with, but then you convert those files into JSON format by explicit coding or by using OpenAI tools, and then you fine tune. So this is another requirement which we have, which another demo use case. Other than that, in interest of time, I'll not be able to go through other use cases in great detail, but just to talk about so when you do GPT-3 fine tuning, you don't do it just for question answering. So the best thing about GPT-3 is, one of the best things about GPT-3 is it allows you to actually do lots of things which previously you would have required other machine learning models. For example, it helps you do entity classification. Earlier, you would need NLT or SPACY or maybe Hugging Face transformers to do it, right? You wouldn't do it using GPT-2, for example. GPT-3 enables you to do it. GPT enables you to do classification, and I'll just quickly show, in interest of time, 4 use cases where we actually implemented that, and it will be helpful to talk about those industries where we did that. So one of the use cases, for example, for the pharma industry, where for example, you have a text around COVID and you want to summarize the text. Now GPT-3 is a document is a model which is not fine-tuned on COVID for sure, as in COVID is a very, as in any biomedical text, right? It's a very intensively domain-specific text, and you need to fine-tune your model heavily for a summarization exercise. For that, naturally, what one would do is one would look at abstracts which have papers which would have the entire documents and then abstracts. For example, if you go to the COVID, the World Health Organization's website, so there are thousands of papers around COVID, and you could simply take any one of them, a few of them, take out the body and take out the abstract, put it together and do summarization, train the model, get it done. So this is a very important use case. So naturally, people would like to read the abstract of a paper, right? And people would like to create the abstract of a paper, as in if you have the content first, right? You want to create abstract. This can help you in content writing. You may have a use case for GPT-3 around education. So you may be a teacher and you want to generate quizzes for your students. You want to generate physics problems now, or the way Abhilasha was saying, you may want GPT-3 to solve math problems for students. Now, a human being finds it difficult to solve math problems sometimes, right? as in depending on the level of complexity. But then if you have a GPT-3, which is trained on certain specific documents, you could as well ask GPT-3 to get a particular problem, right? So you could ask GPT-3 to give you a numerical which uses, say, Newton's third law of motion and kinetic theory of gases. But you need to give it a few examples. But then once you give it, you could take any, say, physics 11th class physics textbook for it, because those topics are covered generally in class 11, for example, and you could fine tune that, and you would be able to get an output. In this case, you'll be able to get a list of questions, a list of numericals, which would have that. So this actually releases the headache of a teacher who, in terms of preparing the best question answer, it at least helps. The teacher would still, of course, do a double check, but at least helps in that direction. Similarly, you may be a fan of racing cars, right? And well, you may want to know something specific about racing cars. Now it's a very, very specific industry, right? A very niche industry. Now you may have a model, you may just ask GPT-3, it won't give you a very detailed information around history. GPT-3 is not meant for racing cars, right? But if you take the document around the history of racing cars and intensively train GPT-3 on that, for that you would be able to get information with the help of a fine-tuned model. So another use case where you can do is a customer feedback. This is one of the most important use cases for any business. So a customer gives his or her feedback, and you want to classify that feedback. So this is a classification exercise. You want to rate that feedback, right? So maybe average, or maybe okayish, good, very good, bad, very bad. So this is a classification exercise. Now classification traditionally is done using statistical or say deep learning models. You don't use language models for classification, but with GPT-3 you can do it. So you take a set of comments, you provide those whatever labels you want to provide as regards the kind of feedback it is, and then you train GPT-3 that way, and then it will give you the feedback. So it's GPT-3 fine-tuning doesn't help you just do question answering. It helps you do summarization, helps you do say question generation for that matter. It helps you do entity classification. It helps you as in, so entity recognition and entity recognition classification are different requirements, right? So in some cases you may want to know what entity I'm talking about. So it helps you do it. In some cases you want to classify your comments. It helps you do that. So that was what I wanted to present as regards the fine tuning of GPT-3. And it's important to mention that GPT-3 fine tuning is obviously because everything is like not a free service. So when it charges, and naturally it should. For that, the pricing has to be considered proportionally. So generally, I've been using GPT-3 for a long time, but when I use it normally for my requirements, the pricing there is the charges are quite low. But then with GPT-3, when you fine tune your data set for a specific requirement, you got to be very careful, because it depends on the number of tokens that you're using. It, of course, it depends on how long your data set is. It doesn't help if you output everything in your data set, right? For example, for a COVID scenario, if I, for example, take a data set which is like 10 pages long, right? And if I just twice it, it wouldn't even process it. It limits the number of tokens. It's like 4,096 tokens, well, 2,048 tokens in some cases. It needs to be taken into consideration. But then the point is that fine tuning is an exercise which is not done so regularly, because when you are doing fine tuning, do it the first time the better way, right? By do it again and again. And in context of it, I'll just jump on to the next important thing which I wanted to discuss as part of this, and that is the MLOps around GPT-3, or for that matter, the best practices around deploying language models. So we at WalkingTree Technologies have a great experience in NLP and particularly transformer-based architecture. So be it BERT, be it GPT-3. So they have been used for different requirements. For example, when we would work with BERT, so BERT was used for answering, say, short answer type questions. GPT, so we have been using transformer models for a long time. So GPT-3 came in 2020. Earlier on, it was GPT-2, which came in late 2019. Well, GPT-3 came in 2020, but then it was only till in November last year, 2021, that it was kind of made open to developers. Earlier there was a wait list. Now there is no wait list. You simply, within few seconds, you can create your account, get an API, can start working around GPT-3, working with GPT-3. Earlier you had to wait for because you had a wait list. And this fine-tuning capability. So the real use case of GPT-3 comes with fine-tuning, because it's like you can't just take a fresher and use him for any industry, right? You have to fine tune, you have to train every fresher. You have to give him customized training for the kind of job you want it to be done. So similarly, for any kind of industry, if GPT-3 is to be made use of, it has to be fine tuned. And one of the reasons that this GPT-3, despite having been released in 2020, couldn't be used. So there are already 300 applications, but then why are not there 3,000 or maybe 30,000 applications around GPT-3. The reason is that till November last year, you couldn't fine tune it. And then it had limited utility. Now, for the last 9 months or so, you have the fine tuning capability in GPT-3. And this has actually opened lots of possibilities around it. That's why it's quite popular. But when we worked on this earlier, on its previous avatars, as in GPT-2 and GPT itself. So what we found was that of course, there were different models even in GPT-2, and the higher models were more accurate. But then GPT-2 was limited in terms of being able to generate sequences. It wouldn't do entity classification, and certainly not as accurately. So you could force it to do, but it wouldn't help, right? You would rather use some other thing to do it. And BERT was like, it would just help you in answering questions, say, or maybe generating sequence or fill in the blanks for very small phrases, right? It would never generate sequences for you. It was never meant for that either. But one thing which we have learned from our experience of these language models, and it's a rich experience, and because we have worked with different industries, and of course we have customers from India too. One of the problems which we face in NLP is, and as regards this, I'll discuss the MLOps pipeline, is that many of these language models, and GPT-3 is no exception, are trained on a certain data set. For example, Scott was mentioning it is trained on the common crawl data set and some Wikipedia information and some books, but they are more or less English documents. Of course, GPT-3 enables translation as well, and in fact, we use GPT-3 for an internal use case of translation. But then GPT-3 is not something which has been fine-tuned, say, for example, on Indian documents, or say, example, on documents related to ancient Rome, right? Or other, say, documents from Africa. Of course, it has not been trained on that. What happens because of that is, if you have a requirement where you are processing documents which have Indian entities, maybe Indian names, and maybe Indian festivals, and other things having to do with India or with any other country for that matter, it could be a certain region of the United States or a certain region of Europe, right? Regarding which, people would be, of course, aware of it, but then not much has been published in terms of language which is used for training GPT-3. So those would be the use cases you would lose out. For example, we were working till some time back on a resume parser, and we recognized that it doesn't simply detect even Indian names for that matter, leave aside other things. As in Spacey, for example, is not able to detect Indian names most of the times, as in names of people most of the times. And we realized that of course it performs very well on foreign names, as in English names and names from other parts of the world in Europe and United States. So we needed to find Spacey on that, but then why to use Spacey when you have such a model? The general architecture is this: for any use case which you have, and NLP is no exception, you got to have ground truth storage, and you got to have databases where somebody to start with will help you in curation. We did fine tuning of GPT-3 for some 6 examples, showed you 2 examples, but we needed strong fine curation, dataset curation for that. Once you take the databases, you take the training data, you generate a fine-tuning dataset using the method which I've just described. Then you do model retuning. Here I'm specifically calling it retuning because it's not just one stop. It's not a once and for all exercise. You have to fine-tune GPT-3. Every time you get a fine-tune GPT-3, and then you have to have an evaluation and monitoring mechanism around it. Now it depends on what kind of framework you're using. If you want to have an in-house pipeline, you better take the outputs, store them somewhere, and then match them with your, as in what to say, the ground truths. And for example, if you already have a working pipeline around AWS where you're using SageMaker Model Monitor, then you would still use the API endpoint of GPT-3 to get the results. But then you could make use of some good reports which are provided by say Amazon SageMaker Model Monitor, and you could set up alerts based on certain thresholds. So those alerts would essentially help you to measure the performance of this in real time, as in on a daily basis, not real time. And why this is important is because if human beings make mistakes, one of the reasons human beings make mistakes is because they don't keep themselves updated with the latest information. So information keeps changing, more information gets added, knowledge keeps getting generated. You need to be up to date. As human beings need to be up to date, so do machine learning models. And so we just can't be done with tuning of models. We need to have that as part of an MLOps pipeline, an end-to-end workflow, which is actually standardized for an organization's requirement. So this was that, and I think we can come to questions.
Right. Thank you, Shubham, for that. Are you able to see the 2 questions that we have? We have a few more in chat, which I'll read it up. But the first one is from Radhe Saini. Is it possible to match intent and meaning of two different questions?
So the question is it, so let me look at the Q&A chat itself. Is it possible to match intent and meaning of two different questions? Of course it is. You see, and for this, you wouldn't need GPT or also, because that can be done using simpler models. For example, if you just take cosine similarity, right? There are two sentences like the president of the United States is addressing a rally in, say, Texas, and you have another sentence like Joe Biden is addressing a gathering in Houston. They mean the same, exactly the same, right? So even your cosine similarity models would give you similar similarity. For that, you don't need GPT-3. The point is that happens because there is vector encoding of the features. And when you have vector encoding of the features, features which have similar semantics, as in words which are similar in meaning, have closer vectors. And of course, a heavy, deep learning model like GPT-3, which is a transformer architecture anyhow, involves that element. So yes, it is possible to do that. As regards intent, now it depends. Now, there, for example, when we were looking at this customer sentiment analysis, doing this using GPT-3, we came across comments like, and this was for the telecom industry in specific, we came across comments like, wow, your telecom service is the best in the world, and I cannot have a telecom service any time in future. Now, of course, this is too good to be a true comment, right? So the intent here is that the person is disappointed. But then to be able to make GPT-3 do it, yes, you need to fine tune, and you got to have a human being help GPT-3 to do it. You need to do the right labeling for those requirements as you do for any machine learning model. The next question is, what is the metric used to identify if I need to add more prompt to improve the accuracy of the model? It varies from problem to problem. So for example, if you're using GPT-3 for classification, so say the case which we took, right, customer feedback, well, coming to that case again, you need to do classification, and classification in terms of 5 different classes, right, kind of feedback that you're getting. You use GPT-3, you realize you're getting certain results, you already have pre-existing results. Now the metrics for different machine learning problems are different. For certain problems, you, for example, go for precision recall. For others, you go for reference score. For others, you go for area under curve precision recall. For others, you would go for root mean squared error. So depending on whether your problem is, say, classification problem or regression problem, even within classification, it's binary classification or multi-classification, you would change the metric. So I'm afraid there is no single standard metric, because of course it will depend on the kind of problem that you're looking at. So these were 2 questions in the chat box, but I see which type of OpenAI should I use if I need to match 2 different intent and questions scenario. So, well, that's a good question, but as I mentioned in my first answer, so when you say which type of OpenAI, I anticipate that it actually relates to which kind of fine tuning I should do regarding GPT-3, right? So basically, well, one thing is that as Abhilasha was saying, mentioning some 20 minutes ago, GPT-3 is not something which you would have to use only for a specific kind of use case. You would come up with your use case also. For example, that scenario where you give an animal name and you want to generate 3 fun names associated with that animal, or maybe say for a country in Europe, or say for a state in the United States, you want to check, well, I take the name of Texas and I give the names of 3 biggest organizations which are there in Texas, right? And I do it similarly for other, say for California and other states of the US. So the model intuitively knows that the chap is actually looking for big companies from the United States, from those states to the United States, right? So it's a very specific use case, but when you pass prompts, you are able to realize that use case, right? It's like any human being who understands, all right, these are the 2 inputs he has given to me. This is what he's trying to do. Let me give the answer that way when he gives me the new input. Now, which type of OpenAI should I use? I think, of course, for this kind of exercise, if you want to know the intent would be a fixed set of values. For a fixed set of values, you of course have the classification. The problem is the classification problem, right? So you could fine tune GPT-3 for a classification problem. And if you check the OpenAI website, for example, there is a standard documentation around that. In fact, what you could do is the way I explained regarding the sets. So you could have some comments, some statements, and you could have an intent marked against them, which you could use directly. But then as regards the question and answer scenario, I don't think you need to fine tune. So in fact, if you ask GPT-3, right, are these two sentences similar in intent? And there the answer would be reasonable, because when so I have it's a guilty pleasure for most of us, as in me and my team. So we do all kinds of things. So from generating songs, poems, and well, as regards creative learning is concerned, generating quizzing questions around different domains, particularly science and engineering. So you just cannot but be impressed by the capabilities of GPT. So you try it out, you would automatically find it. You would need to fine tune. Of course, for classification, you would need to fine tune, because GPT by itself doesn't know. So it would have some intuitive sense as to what are the different kinds of intent. But then if you want to have a specific kind of list from your side, better fine tune it.
Right, Shubham, yes, there are. There is another question from Joelvis. Is GPT-3 unidirectional or bidirectional?
So GPT-3 is well, of course, I think as Scott also mentioned earlier, GPT-3 is unidirectional. And let me put it this way. So the main difference between, so when I say unidirectional, it means left dependent on context on one side. So what happens, and that's both a strength and both a limitation of GPT-3. But then with GPT-3, you cannot call it a limitation now. So I'll explain a bit. So when you do fine tuning for transformer based architectures, training for transformation based architectures, then you can actually train on the left context and the right context both. For example, what you would do with BERT. So BERT is like a fill in the blanks approach. So you have a statement like the President of the United States declared dash on May 1972. And well, it's a dash, right? You need to look at left and you need to look at right, and then you would try to guess what the answer is. So that is what BERT does. BERT is trained to do it. But GPT-3 is explicitly trained to focus only on the left context. In fact, it is not given the right context. So if you use the same data set for training BERT and GPT-2 or 3, you would, so here for 3, I would mean fine tuning, of course, and for that matter for 2 also. But then if, for example, if somebody were doing the training, right? No, but technically, though, if resources are not a constraint, nobody prevents, right? So if you have to do that, you would mask the right context from GPT-3. In that sense, it is unidirectional. It only looks at the history. It doesn't look on both sides. The other side is irrelevant. In fact, it generates the other side. So GPT-3 is a generative model. It is meant to do it. It's another point. It's all the GPT series, right? As Scott mentioned, it's generative pre-trained transformer. It is meant for generation. It's another thing that we can use those very capabilities of GPT-3 and turn it on its own head to do other things. For example, if you have to use it for question answering, well, it's a generative sequence, right? Give it a few samples, give it a question, at the end of those samples, give it an answer. It is generating a sequence of question and answers then. And then when you give a new question, it generates a new answer for you. It becomes a question answering system for you. Similarly, you give a question on summarizing and provide a summary. It adheres to the prompt and does that. So it's a generative model. It works on, it's unidirectional. It works from the left context side. But there are other models which are bidirectional, but then bidirectional models are not generative models. So BERT doesn't generate information, right? As in it finds the missing information, which is of course useful in some cases, but then it's less powerful than GPT-3 as regards the overall capabilities.
Right. We have a question from Marianne, like about a question on, for example, like what she's putting forward a question like, how do I change my proxy? Does GPT-3 understand the context? In this case, it can be proxy of the vote or proxy for my network configuration.
So GPT-3 would understand for this case, because from my experience, and you as Marine would also appreciate it. So if your question is how do I change my proxy, right? GPT-3, most of the data that GPT-3 would see online as regards proxy would actually be related to internet proxy, right? However, if you are using GPT-3 in an education setting where you're talking about classes, colleges, schools, and then you talk about proxy, GPT-3 understands. So for example, if you give a statement to GPT-3 that, hey, I'm not attending a class, and could you manage a proxy, or could someone manage a proxy? GPT-3 understands what meaning of proxy you have, because of course, GPT-3, like any other deep learning model around language, these transformer models, they go by vector encoding, they have the semantics in place. So similar meaning words and sentences are put together in terms of their vector distances. So GPT-3 would be able to do it for sure.
All
If
right.
you
We
pass
have,
it, if you pass it the normal way, it would take it as internet proxy. If you give a sentence prior to it, it would get the context that you mean a person who wants to put attendance for you.
right. So we have another question from Balaji, and this is an interesting one. Are the results for specific prompts always consistent? Meaning, if I'm using the same prompt at different instance, will the results be the same?
So the results are generally different. So when you use the same prompt at different times, the results are different, but then there is a way you can control that. So as I mentioned, for example, let's take it this way. If you ask me a question, what song would you like to sing, right? Or what poem would you like to narrate? It would depend on my mood. For just as an analogy, right? And I will not give the same answer every time. So GPT-3, of course, doesn't have a mood, but then at a given point, GPT-3 is an API, right? So GPT-2 was an open source thing as well. You could use it, install it, run it. But GPT-3 is only available as an API, and you do not actually know how the internal. So it's a static model, nevertheless. But then I'm sure even OpenAI would actually be fine tuning it for one of the reasons. So they wouldn't call it fine tuning; they would call it training. But then you would have those kinds of varieties around the model. Also, your machine learning models by themselves, right? You leave aside GPT-3, take a simple classification model or a regression model. There is a reason why we do seeding in machine learning models, right? Because you want to replicate the answer. You don't want your model to give you new answers every time. So it's not a problem just with regards to GPT-3. It's a problem across machine learning with respect to deep machine learning in particular, as in deep learning in particular. So that's why you do seeding. So when a normal model, a normal regression model, right, would give you a TensorFlow based model, I mean, deep learning model would give you different outputs at different points of time for even mathematical, as in regression problems, then why not GPT-3, which is anyway language based? But then there is a way you can control it, because if you provide sufficient samples, and it's like you talk to a human being. So if you tell GPT-3, hey, I want you to generate the same sample every time, I'm pretty sure the chap understands that quite well. So you try it out, you would see that, and of course give it a few examples, it would be better able to do it. So when it knows that there is the word same, right, I want you to generate the same prompt, it actually has a tendency, as a child would have, to keep repeating the same thing. And of course you can also control the randomness using temperature. So GPT-3 is like GPT-2 has certain attributes which you can configure, and temperature is one of them. So if you want a different output every time, you would set the temperature towards one end, I think high, and if you want a consistent output, you would set a temperature as low. So for example, for some cases, if you want to generate a poem, right, or creative learning, as in education, you would generally keep the temperature of GPT-3 as high as possible. Why not every time generate a new kind of poem? But if you want to focus on say something like what I was showing, an IRS, information retrieval system around financial services, then you would rather ask it to behave well and just give the same answer. So you would keep the temperature low, right? So the temperature actually is a parameter to GPT-3. It's an inspiration to GPT-3 to experiment more. You keep it low, it behaves more consistently.
Right. I think we just have time for just one more question, and I can see that on your screen from Radhe Seni. If we need to train a model on specific Q&A, then how can, and got answer for all semantic question answers easily, how can, I'm not
Let me try
sure.
and understand. So if you need to train a model on specific Q&A, then how can, and got all semantic questions answered easily. All right, so I think the question is, you want to fine tune GPT-3 around question and answering, and how do you ensure that semantics gets taken into consideration? So Radhe, as I mentioned earlier, so that's a very standard exercise. In fact, you take any question answering data set, and as regards to semantics, so I would say using GPT-3 for understanding the semantics, for getting the semantic similarity, would be an overkill. You could even use cosine similarity. You could just download the Google Word2Vec or Stanford Word2Vec, use those models to convert your words into vectors, and just do a cosine to get similarity. You don't need GPT-3 for it. But of course, if you have to generate, so suppose you want to generate sentences which are similar in meaning, right? Then that for generative capability, you could use GPT-3. but semantic similarity is something which is already given there. So let me just quickly answer the question. So again, precisely just to conclude it. So we already demonstrated some examples, right, where you could just have the passage, a question or a couple of questions and answers associated, and then you could pass it to your fine-tuning job. You could convert in that CSV or whatever format you have into a JSON and pass it, and it would fine-tune. It's a standard practice. Another question which I see is, in GB3 fine-tuning specific to the one who fine-tune, or it become for everybody else? No, so of course, why would it become available to everybody else? So so if I find you in GB3, it is associated with my account. So for example, when I was showing you the list of models that I have fine-tuned, so that for that list also I need to have my API key set as an so that list which I was showing to you. Let me show that command once again. Open AI API fine-tunes dot list. So before that, I need to set my API key actually as an exported, and only then I'll be able to see. There is no way that your fine-tuned model is going to be publicly available unless you share your API key to somebody else. So it's protected, fully protected. You are charged for it actually. So they wouldn't violate that privacy principle at all. Any other questions?
No, I think we are good.
Any study on biases and data? So that is what I was mentioning when I talked about the well, profiles example, resume example. So I in fact was categorical in mentioning that most language models, and of course I started with SPC, but then most language models they are actually fine-tuned on data sets which are English data sets, which are kind of Eurocentric and maybe as in West specific, West centric, and they wouldn't necessarily, they would certainly not perform well on say problems or data sets having to do with the eastern part of the world. So say for India and China, and you need to do again a fine tuning or a class as in well for spacey, or you could build a model around, you could train a model, smaller model around those requirements. But then if you feel that you have to do generation, then you would not actually train a model, you would use GPT-3, but you would fine tune it. So this is a very pain point for most language models, and you have to do it. But then there's an opportunity in the industry, of course, and we exploit it a lot. Any other question? How can we detect data drift and the model drift using GPT-3 model? Well, I think it's a simple problem, right? So well, about 20 to 30 minutes ago, Abhilasha was talking about doing a math problem with GPT-3, right? So what is the data drift? Your data drift is so today you train your model on one kind of data which has some statistics and constraints. So your, for example, some columns can only be positive, some columns may be positive or negative. The mean, median, and variance should be in so and so range. Those are stats and constraints which your data has. Now assume that you had trained your model on data prior to COVID, and with COVID you got an altogether new data set, right? There were huge spikes in certain countries. Then that your data would not hold, your model would not hold. So there's a data drift. But then that becomes an independent mathematics problem, right? So why not? So give two arrays to GB3, ask it a question whether they are different in terms of their statistics, bias and variance, as in mean, median, and standard deviation. And but you fine tune it for that exercise, as Abhilasha was mentioning. So when a GB3 can solve numerical problems for you, and that is one of the best use cases of GB3, in fact, as in for education, why can it not just detect data drift where you only have to calculate averages, right? It of course can. And as regards model drift, so well, would GPT-3 detect its own drift? No, certainly not, right? Wouldn't make sense. But you can do it in one way, that you can have so it's like this: you take GPT-3, you invoke it for a particular problem, for a use case, and then you collect the responses, and then you have a standard set of responses. So say I'm using GPT-3 for a classification exercise like customer feedback analysis, and I get some results from GPT-3, I put them say in a database, and then I have a standard result as well, and I'm using GPT-3 again to do the comparison. So GPT-3 is evaluating itself, but it's actually a forced evaluation of itself, right? Of course, no model can evaluate itself. So of course, there's a component of testing and validation that every model does, but that would have been the case as regards what Scott was mentioning. So when they were training GPT-3 on those Common Crawl and Wikipedia and Book 1, Book 2 documents, right? There they would have taken those things into consideration. But now you have GPT-3 in place, a perfectly available model. You wouldn't use it for, it doesn't make sense for it to evaluate itself. You can actually put a pipeline around it with multiple problems solved using GPT-3, but then it's not self-evaluation, can't be called self-evaluation. In fact, I would just add on because it's relevant here. So it's worthwhile mentioning because we are talking about AI industries and machine learning. So there was a time when these machine learning models, especially language models, were just restricted to language problems. But with the onset of GPT-3, and particularly, and I'm emphasizing again and again, with the onset of fine tuning, and it is only 9 months old, the gambit has actually expanded. The plethora of machine learning problems which can be solved by GPT-3 is actually, so it's not a plethora now. It's a big set of problems which you can do. So I mean, I would just go to the extent of saying that if you have 10 machine learning models, right, you could have decision trees, random forest, isolation forest. You could have, say, Hugging Face transform, which for specific, not Hugging Face because it's anyway transform, but still it's not trained on that enough data set. You have 10 different models, and there's a high probability that you can replace those 10 different models with GPT-3 because, and the benefits are many, right? You will not have, it's easy to integrate, it's easy to do also. You will just need to pass a few samples. So if you want to fine tune it, you don't need that many samples after you have fine tuned it. However, if you want to do it the prompt way, then you will keep passing samples. There's another question. How to smartly train the GPT-3 models, optimizing compute and costs, cloud, on-premise? Any example of on type of GPUs used? So, well, as regards the question on how to smartly train the GPU, so you don't train, so you're fine tuning, right? If the question is you want to train it, so I'm afraid it's a very costly thing, right? Because GPT-3 is like, if I'm not wrong, it's 175 billion parameters, right? And as Scott was talking about the compute power required, petaflops, you wouldn't train it. But then I think because this is on fine tuning, I'll answer the question from a fine tuning perspective. See, there are 4 models. Now it depends on what kind of use case are you looking at. If you are purely looking at a generative use case, say around education, and you want to generate short stories and say poems, you want to generate Shakespeare content, Pierce content, you have 4 models to work with, right? You have DaVinci, Curie, Ada, and Baggage. You better go for fine tuning of models which are lower, as in less advanced. They even cost you less otherwise, and you anyway don't require that level of specificity and complexity which comes with higher models. So that is one way. The other way is because, of course, the fine tuning depends on how much data set you use, because it is actually token based. So if you go to the Open AI website, it will show you the pricing around GPT-3. So it's actually half of what you would. So fine tuning is actually priced at half the rates, the rates at which you would do other exercises in terms of usage of GPT-3. But then, but it is much more compensated on the other side by the number of tokens for which you do fine tuning. So you never do fine tuning for, say, 2 examples. In fact, if you go by the advice of OpenAI, they at least recommend a couple of 100 examples. But I must appreciate even that thing, because in machine learning in general, no data set less than 10,000 records actually counts for training of a model. GPT-3 is allowing you to do fine tuning with just a couple of hundreds, and couple of hundreds essentially means like 200, 300, 400, 500. You don't even need to go to 1,000. Of course, if you can, you better go. But then you can use as less tokens. So you would rather go for smaller variants or less complex variants of GPT-3 and fine tune them. And as regards the cost, so I haven't seen any parameter where I can actually specify on what kind of instance I want to do the fine tuning, because to be frank, it is like a managed service. So you of course ask it to fine tune a certain data set, but as with any managed service, for example, if you're using, say, model monitoring or say Amazon forecast, it takes your data set, and based on your data set, it decides what kind of algorithm it has to apply, right? So if it is a math problem and if it is a poem problem, right, of course there's a ton of difference between them. So wouldn't use the same infrastructure. This is my intelligent analysis on that, as in guess on that. And any type of an example of type of GPUs used, well, I'm not sure whether they use GPUs of a particular kind, but then of course for that kind of exercise, because from my experience of fine-tuning at least a couple of models, right, as in around 7 or 8 models, shows that the fine-tuning exercise is not very long. So even if you have a data set around 1000 records, you can still fine-tune it within 20 minutes. So you of course can't do it without GPUs, right? And I think they would be using TPUs for that, certainly. And this example which I was talking about around fine-tuning on the food dishes data set, right? This had some so this had like information on 44 European countries, and for each country we had like 100 examples. Not 100, it was less than 100, but then you had still a good data set overall, but it got finished in like 15 minutes, right? Fine. Then it would require GPUs for it. It cannot do with CPUs. What's the kind? I don't know, frankly. I will have to double check on that. Because I mean, so if the question is, so GPUs are of different kinds, right? So you would have NVIDIA and you would have from other companies, and even their processing power would be different. I'm not sure which exactly are used. We'll have to search on that. But that is none of our business anyway. There are some parameters which you can control by passing, for example, something in prompt. So if you want to, for example, you want to give a particular name to your model, you don't want OpenAI to decide the model name. Well, you pass it as a parameter, it takes that. Similarly, there are other things, but GPUs, I'm not sure that you can actually. I actually didn't come across a documentation where it talked about the types of GPUs that they were using.
All right. Thank you, Shubham, and thank you, Scott and Abhilasha. And thank you, everyone. That's all the time we have today. This webinar is obviously a part of a series of webinars that we are doing on GPT-3 and NLPs in general. So you should please keep a watch out for more of these and many more coming your way. So thank you, everyone.
Thanks, everyone, for the questions.
Yeah, thanks, everyone.
Thank you.
I think there's one more question here. Or we have. I think you can. These questions can be taken offline, right? As is a comment.
Yes,
Yeah.
of course. Yep.
Sure.
By the way, I think those are V100s that were used as far as GPU, so probably NVIDIA. Yeah.
I see. Oh, thanks, Scott, for that. I wasn't aware, actually.
Yep.
Thanks.
All right. Thank you, everyone.
All right. Take care.
Bye.
Good end.